Welcome to our review on measuring rates. So what we're going to do in this little presentation then is to go through how we can actually use some data from an experiment to work out the rate of a reaction. So the first thing we actually need to understand then is what exactly a rate of reaction is. Now if you're looking for the definition there, quite simply it's the speed at which a chemical reaction will take place. And what we're actually going to do to work that out is measuring the amount of product made in a fixed period of time. So what we've got here then is the experiment setup that you would use in order to measure the amount of gas that's made during a chemical reaction. Now they do like to ask you about this, so make sure you can identify and label the gas syringe and also the conical flask particularly. Just to give you an idea of the kind of chemical equation you might well see for this, I've given you the example of calcium carbonate plus hydrochloric acid makes calcium chloride plus water plus carbon dioxide. Now obviously we can't measure the amount of water we make because where we've got a hydrochloric acid, which is a colourless liquid, water is also a colourless liquid, so that wouldn't be much use to us. The calcium chloride is just going to dissolve in that solution as well, so again it's not easily measurable. So when we're making the gas like carbon dioxide, that's by far the easiest of the products to measure. So what we actually need to do then is understand that chemical reactions are going to continue until one of the reactants has run out. Now the first of those reactants to be used up is known as the limiting reactant, because what it's doing is it's limiting the actual progress of that reaction. Now when we're actually considering what to do with the data we collect from these experiments, the key thing to think about is how can we present the data in terms of a graph. If we're referring to continuous data, so that's things like obviously the time, the volume of gas, etc., then because they're continuous, that means we should use a line graph. The other type of question we might well get on our exam paper about this is that you'll be given an actual graph of experiment results like the one on the slide here. Now what you need to make sure you can do is to explain what's actually happening there. So at the beginning part there between 0 and our 60 seconds, what we can see is the reaction is happening at its fastest rate, okay? So the steepest part of that line tells us that it's happening at the fastest rate because we're making more gas in a short space of time. As we go further up, so between kind of 80 to 120 seconds, we can see that the line's starting to curve quite considerably. Now as soon as we get a curved line, what we know is that it's slowing down, okay? So that tells us that we're starting to run low on one of our reactants. And eventually when we come up to about 150 seconds, we can see that we've got that horizontal line which tells us that the reaction has stopped. So what we can see there by reading off, it's taken 150 seconds and we've produced 60 centimeters cubed of gas. So just make sure that you can read those graphs to see what they're actually showing you, because they can ask you to interpret what these graphs show. One other thing to remember is that when we're talking about the amount of product we make, that is directly proportional to the amount of our limiting reactant. So what that means is if we double the amount of our limiting reactant, we are going to double the amount of product. If we halve the amount of our limiting reactant, we halve the amount of product. So just be wary on this one. It's usually a 1 mark question, but they will sort of ask you what happens to the amount of product made if we double the amount of our limiting reactant. If you just say that it increases, you're not going to get the mark. You've got to be specific and say it's going to double. Okay, so look in the question. If it has any words like double, halve, 3 times as much, then when we're talking about the amount of product we make, you must use that exact same phrase. The last thing to understand then is the units that we're going to use for this rate. Now, depending on what we're measuring determines what units we're going to use. So if we're measuring a gas, then what we're going to use is centimeters cubed per minute or centimeters cubed per second, depending on the timescales involved. If we're measuring the mass of the product we're making, then that's going to be in grams per minute or grams per second.